Welcome. Today we're just going to look at the concept of the antiderivative. Obviously, when we start thinking about that, it works similar to if we start looking at x squared and the square root of things. So that's probably the simplest example I can explain to you. If we are looking at this, so what it's saying is the derivative of f of x is equal to f dash of x. Well, the antiderivative of that then is f of the x. So you'll need to do some examples out of question 6c. So I'm just going to do a couple of similar ones for you. So let's have a look at this one here. So if we've got to find the derivative of, say, something like x to the 7th, that's going to be equal to 7x to the 6. So if I want to find what the antiderivative of x to the 6 is, then what I need to do is get rid of this value here and bring it across at the side. So obviously when we start looking at that, so that would become 1 on 7 of x to the 7 dx. That's going to give me x to the 6. Alright, so that would be, this value over here is the antiderivative of x to the 6 by using the concept of making those two things equal. Alright, so another example, if we use, say, something like e to the 4x plus 3, if I do the derivative of something like that, so when we go and we do the derivative of that, well, it's easy to do the derivative of an exponential. It's simply the exponential plus the derivative of the power, which is going to be 4. So if I want to find the antiderivative of e to the 4x plus 3, that's what I'm trying to find the antiderivative. I need to get rid of this 4. So the easiest way to do that would be to divide both sides by a quarter. So then that would become d dx of 1 on 4 e to the 4x plus 3 is equal to e to the 4x plus 3. So there's the antiderivative over here of that particular function. So concept is we'll use an antiderivative, this sort of idea, to try and come up with a rule that we can actually use to find the integral, because the antiderivative is in fact the integral of the function. Rather than trying to do it by inspection and by this process, if we can come up with a rule, then that would be fantastic. Alright, so if you look on the formula sheet that I've given you, all the rules for doing the integration are actually on there. Alright, so you'll find this one here relates to the concept of, if you're doing the integral of x to the n dx, then the rule is that becomes x to the n plus 1 all over n plus 1. This rule here would be the integral of e to the ax plus b dx, then that's going to be equal to 1 over a e to the ax plus b. Don't forget that we would have to add on the c value as well. Alright, so that will be all we're going to do today. I'd like you to have a go at exercise 6c and have a go at those antiderivatives and thinking about the opposites of what you derive as the way of doing those. I'll talk to you in class, and good luck with those questions. Bye for now.